In this problem, we are given the following simple circuit diagram, and we want to find the impedance ZA of B. We are given the number of turns for our inductors here and here, and we are also given our ZL right here in rectangular form, which will represent this. We need to find our ZA of B. To find our ZA of B, we need to set up an equation. Our ZA of B is going to be equal to the number of turns, so this N1, over our N2, and this is going to be squared. And this N1 and N2 is going to be these values right here. It's for the first set of inductors, so it's going to be this. Next thing we're going to do is we're going to multiply this by our CD. Now our CD is going to be the node here and the node here, and if we had even more inductors, we would have an EF like this, but we only have CD here. And for our CD, we need to write an equation for this. So our Z C of D is going to be equal to, and then we're going to do the same thing where we have our N1 over our N2, and this is all squared, which will be these inductors right here. That'll be the number of coils here. And lastly, we are going to multiply this by our ZL since we have nothing left here. We don't have anything, so this is just going to be our 200 plus J times 150. And that is how we're going to go about solving this problem. Now we're going to write everything in one line and plug them in. So we have our ZA of B, and this is equal to our N1 over N2. This is going to be 50 over 1, and we're going to square this, so this is basically going to be 50 squared. Now we are going to multiply this by our Z C of D. This should be a Z C of D up here. And we know this is our N1 and N2 of the next part, so we're going to have our 1 over 25. So we're going to multiply this by 1 over 25, and this is squared. And then we know we're going to multiply this by our Z of L, and our Z of L is going to be 200 plus J times 150. And in doing this for the first part, we are going to get a 4 here. Now we can multiply this in, and we're going to get that our ZA of B is equal to 800 plus J times 600. Now it's asking us for the magnitude and the angle. That means we need to convert this from the rectangular form to the polar form. And to do this, we are going to have a Vmax equal to the square root of our real number squared plus the imaginary number squared. And then we're going to have our angle equal to the tangent -1 of our imaginary number divided by our real number. And after we do that, we are going to get for our magnitude 1000, and then for our angle, we will get 37 degrees. And that's how you'd go about solving for this problem. There's a playlist in the description below the like button for more network analysis problems, as well as notes that'll help with this material and the rest of the coursework.